Hello again, everybody. I just want to go over the two homework assignments that we had last week. So let's start with this one. It says Kepler's first law. The first thing that you need to do is in question 1, they're asking you to find the eccentricity. So if you want to find the eccentricity, you go to page 1 of the reference table, look for the equation, E equals d over L. Then what you do, you're going to measure the distance between the foci with a ruler. Don't have a ruler on me at the moment, but I believe that came out to 3.3 centimeters. And then you would figure the major axis. What you're going to do there, you're just going to take a straight edge. You're going to draw a line from one end to the other, like that. That's your major axis from that end of the ellipse to that end of the ellipse. I believe that came out to 10 centimeters. And then you just do the division, no units, and it should be 0.33 repeating. And I think, as I told you last week, when you look at the reference table, page 15, at all the eccentricities, just a way to remember how many decimal places to go in, you just look at all the eccentricities here and you can see it's all 3 places in. So that's the answer to part A, calculating the eccentricity ellipse. They even tell you the nearest thousandth. And then they want you to state how the eccentricity of the given ellipse compares to the eccentricity of the orbit of Mars. So what you would do, you would just look over here for the eccentricity of Mars. And here's Mars, slide over. The eccentricity of Mars is 0.093. And I would say then Mars is 0.093, the given ellipse is 0.333, so I would just say the given ellipse has a greater eccentricity than Mars. That's the first question. The second question is just doing math. What is the eccentricity of an ellipse in which the distance between the foci is 2 centimeters and the length of the major axis is 5 centimeters? Again, E equals distance between foci over the length of the major axis. Distance between the foci is 2. Length of the major axis is 5. That's 2 cm over 5 cm. I believe that comes out to 0.4, so you should have gotten D. Which planet's day is longer than its year? And they even tell you period of rotation versus period of revolution. You go to the reference table, and the only one that has a greater period of rotation than its revolution is Venus, right? Because Venus has a period of rotation of 243 days, and its revolution is 224. So Venus is the answer for number 3. Which event takes the most time? You just have to go on the reference table and compare all these things, and what you should have gotten for number 4 is choice A. Go to page 15 of your reference table and look at that solar system data chart. Okay, let's go to number 5. And number 5 says, what does number 5 say? It gives you this whole graph, and you're going to use this graph for 5 and 6. And the diagram below represents the position of Earth and Mars and their orbits around the Sun when they were closest in the year 2003. So they're right here. That's when they were closest together. Which diagram represents the position of Earth and Mars approximately 1/2 of an Earth year, or 183 days later? So look, here's Earth going around the Sun, and we know that the Earth takes 365 days to do a full revolution. So therefore 180 days means it would be right here in its orbit. And the only, well, there are 2 choices that show that, C and D. See that? C and D. So we can eliminate A, we can eliminate B. We want to see how long it takes Mars to do its full revolution around the Sun. That's 687 days. So 183, that's about 1/3 to 1/4 of the way. And it looks like, to me, the one that looks like Mars is moving 1/4 of the way. We'll put it right about here. That would be choice C. Okay, let's go to the next one. Mars reaches its closest distance to Earth approximately every, well, you're going to use the graph here. Here's the closest distance right there in 2003. The next time we reach the closest distance is in 2019. That's 16 years, and then if you just keep going, it reaches its closest distance again 16 years later. So choice A for number 6. Let's go to the last sheet. And now they give you this whole blurb, newly discovered planet, and they're asking you compared to the period of revolution of Mercury and Venus, this newly discovered planet's period of revolution is, well, we're looking for its period of revolution, and I believe it told us somewhere in there. Oh, it basically, every time you look for the numbers, you would see that its period of revolution is, you know what, I don't know what I did here. I just know that A is the answer, so just go with that for now. I'm not too worried about that. And then number 8, which planet in our solar system has the most circular orbit? So I don't know if you remember, I told you eccentricity is always a number between 0 and 1, and the closer you are to 0, the more it looks like a circle. So you're looking for the lowest eccentricity. I noticed a lot of people flip this backwards, this question. So the lowest eccentricity is the planet that's closest to 0. Look here, Venus actually has the lowest eccentricity, 0.007. I mean, that's almost a perfect circle. So Venus would be the most circular. And then the least circular orbit would be the opposite. You want the highest number. And if you take a look, the furthest away from 0, it's very obvious, Mercury, 0.206. So Mercury would have the least circular orbit. That takes care of the first law worksheet, and hopefully that helps. And I will do the other worksheet in another video.